A very good morning again to honorable judges and also other members of the floor. Our team from Curtin today would like to introduce you guys a very new project in which we wish to recycle and reduce the amount of waste loop oil that we put out per day and turn it into a much more desired product, which in this case is gasoline. Our team has 3 members. Sufei is going to talk more to you guys about the introduction to the problem and also the process that's involved. Jessica is going to talk extensively more about the NACES and also very technical aspect of the problem. And lastly, I would like to introduce you guys to the sustainability solution, process economic analysis, and lastly, final comparison trade-off as to why we should carry on this project itself. Over to Sufei.
Ladies and gentlemen, along the history of humankind, we have been focusing too much on building factories and also development of the industrial to just better improve our living life. But we tend to forget about the recycle, reuse, and also the proper way of disposal. And each year, a huge amount of solid and liquid waste was being pumped out directly into the environment, especially our water source. And in the case of lubricating oil, as you could see that the devastating environmental impact that after the water was being contaminated and effect on the animal that was been living in the water. And for your information, a lubricating oil is a product from the process of cracking crude oil, and it was mostly being used in the machine to facilitate the movement to reduce friction. And according to the records, we could reach up to 1.4 million tons per year globally. And in Malaysia, it's written that 0.4 million barrels per day was being used. And on a world statistic, the consumption of lubricating oil can be up to 1.4 million tons annually just for the Europe country itself. So here, we attempt to turn this waste lube oil into a much more profitable product, which in this case, we choose gasoline. Why gasoline? Because we anticipate that it's able to achieve 25.5 ringgit Malaysia per gallon in the year 2040. And we can foresee that for Malaysia, we will need 12 million tons per year for the gasoline use. And so here, we think that it's a very good choice for this project because we attempt to create a new alternative method by producing a very desirable product, which is gasoline. And by doing this, we reduce the waste and also making money at the same time because we are using the product from another process as our input. Now, going on to the chemical process, there will be 2 main ones that will involve. The first will be the hydrogenation, which involves the hydrodesulfurization and also hydrodenitrogenation. During this process, sulfur and nitrogen was being removed from the waste tube oil to further prevent the contamination of different products during the process in order to obtain the specification, and also to avoid the pollution of nitrogen and sulfur oxide from the gasoline product. And as you can see for the both reaction, hydrogen sulfur and ammonia was being produced through the removal of hydrogen and nitrogen under a specific condition, which is 300 to 450 degrees Celsius, and by using the nickel molybdenum as the catalyst. Going on to the next process, which is the fluid catalytic cracking FCC. In this process, 3 major units was being involved, which is the fractionator, reactor, and also the regenerator for the zeolite catalyst itself. And during this process, the long, heavy hydrocarbon chain is being cracked down to produce gasoline, naphtha, diesel, and also other byproducts. And the advantage that we choose this FCC is because it tends to give us a very high yield of gasoline product, and the using of catalyst provide a safer process and also lower the cost of consumption. And the feasibility of this process easier us to control the entire process for the gasoline product. Now pass on to the next presenter.
Thank you, Sufei. The conversion process of waste lube oil to product gasoline can be converted into 3 main stages, which are re-refining, hydrocarbon cracking, and fractionation. The first stage, re-refining, is to clean the waste lube oil into a usable base oil by removing impurities and byproducts such as asphalt and naphtha. For this process stage, we have compared 3 different processes, which are hydroprocessing, acid clay treatment, and solvent extraction. And based on our comparison and evaluation, we have chosen hydroprocessing because it produces higher yield and product quality compared to the acid clay treatment. And unlike solvent extraction, the effectiveness of hydroprocessing will not be affected by the quality of the feed. And this point is very crucial in reality because, yes, in reality, there are various grades and quality of waste with oil that are collected in the real industrial situations. Now let's move on to the next stage. Hydrocarbon cracking process is used to break the heavy fuel oil into a lighter desirable hydrocarbon such as gasoline and our byproduct diesel. In this stage, we have also compared 2 different processes, which are FCC, stands for fluid catalytic cracking, and hydrocracking. And eventually, FCC is the selected process because it is cheaper and safer to operate due to the presence of catalyst regeneration units. And also, it doesn't require the use of hydrogen supply. Besides, FCC is more preferable in this project because it produces greater portion of gasoline rather than byproduct diesel. And we have introduced zeolite catalyst into our FCC process because we want to improve the conversion of cracking reactions. Finally, the products that comes from the FCC unit will enter the fractional distillation column to be separated out into various streams of products such as light olefins, gasoline, diesel, and heavy fuel oil. Now let's move on to the next slides to have a clearer picture of our process flow through a block flow diagram. In the hydrogenation process, hydrogen gas enters the PFR to remove sulfur and nitrogen from the waste fuel oil. This requires hydrodesulfurization and hydrogen nitrogenation reactions, and this reaction respectively produces hydrogen sulfide and ammonia. This sour gas will then remove in its absorbed column by using a large amount of water, and eventually sour water is removed as a waste, and the hydrotreated waste oil then enters the FCC process, and the desirable product gasoline will enter the fractional distillation column to be separate out from the other byproducts. From this block flow diagram, we have generated a process flow diagram. To see so we can see all the operating conditions and the equipment, major and minor in our plant. As described earlier, hydrogenation occurs in the PFR, catalytic cracking in the FCC unit, and the fractionation in the fractional distillation columns. We have also simulated by using NACES for this plant, and noted that hydrocarbon cracking and fractionation process occurs simultaneously in this FCC 100, in this NACES. And based on our utilities analysis generated by NACES, we have found out that the PFR consumes the least amount of cooling water compared to the other equipment, as you can see from this table. This is our utility stream tables, and we can see that our plant consumes cooling water the most, and it's mostly consumed by cooler E104, which is used to cool down the stream 11, which I will mention that again in the later slides. And based on our mass balance, our plant produces convert about 12 kg per second of waste oil into about 4 kg per second of product gasoline, which is about 35% conversion. And based on our energy balance, the heater E102 use the most energy in our plant. And let's go back to the simulation, the flow sheet earlier. As you can see, the heater E102 is used to heat our feedstock waste oil. And this is the S11 that I mentioned earlier. And don't worry about the energy consumption because we have proposed a way to minimize the energy consumption by using heat integration and pinch analysis. We can introduce heat exchanger at this stream 11, 24, and 25. And we use the feedstock stream to enter into each of these heat exchanger. Stream 11, heat exchanger at stream 24 and 25 to recover the heat that is produced by these respective streams. This will heat up the feedstocks and eventually will reduce the amount of steam required for heating. Thank you.
Thank you, Jessica, for a very extensive explanation about the technical aspect of this project. So next, I want to guide you guys through a bit of basic sustainable solution, which means we predict the environmental impact and other impacts it would have onto the system itself, and therefore propose certain mitigation measures itself. So the first thing is biophysical. So of course, when this operation comes into play, we would have certain effects onto the fauna and flora system itself. So therefore, we would like to conduct proper vegetation and also wildlife habitat conservation, at the same time impose strict anti-erosion control to make sure that the soil being used is not really being affected by this project. The second form, very basic, which is pollution. When it comes out in a form after the sulfur and nitrogen is being removed out from the system itself, therefore we would like to vent or flare this emission gas properly, abiding to the Malaysian government law, and at the same time we would like to disperse oils into smaller objects to mitigate this problem as well. Lastly would be the social impact. Of course, during the construction and operation period, there will always be affected on to the resident living near there in terms of noise, pollution level, and the landscape view. So these things we would like to conduct human health and risk assessment properly to ensure that these risks are being minimized. And lastly, in the trade-off slide, I will explain, even though with this certain effect, we would still like to carry on this project itself. So next, perhaps one of the most crucial part would be process economic analysis. So our assumption is that the exchange rate is 1 USD equals to 4 Malaysian ringgit. The construction period will take 2 years to be done, and also project life take 25 years, and about 10% of margin price will be put into this because the gasoline needs to be added on to the additive in order to be commercially sold on the market itself. We're using land factor method with two variables. First is a corporate tax that we have to pay, and secondly is the price of gasoline. So for base case, we enjoy 24%, we have to pay 24% tax, and the price for gasoline is roughly near to 2 ringgit per litre. For the best case scenario, we enjoy our tax exemption, we will only have to pay 7%, and the price for gasoline goes a bit more higher than 2 ringgit for a litre. For the worst case scenario, we have to pay 30% the amount of tax, and at the same time, the price for gasoline hits an all-time low of 1.62 ringgit per litre. These are taken based on the previous 10 years of the Malaysian gasoline price itself. So, for the base case scenario, we would enjoy a profit of 57 million ringgit per year, and at the same time, the payback period will only be 6 years. Now, for the best case scenario, we enjoy 86 million ringgit per year, and at the same time, the payback period will only be 4.5 years. What about the worst case scenario? Worst case scenario will only enjoy 24 million ringgit, and also the payback period will take 11 years to return the money back to us. But fear not, because we have an alternative to this to make sure the operation is still running by selling the byproducts of the process, which is diesel and naphtha itself. It will reduce the payback period into 7 years. The reason as to why our team choose not to sell these type byproduct in the best case scenario and in the base case scenario is because we believe that the essence of this project is to reduce the amount of waste that we create out and also save the environment. So we think that the reason why diesel and naphtha we wouldn't start in the first place is first, the demand for it within the Malaysian market isn't that high compared to gasoline, and at the same time, the pollution impact that diesel and naphtha leave on to the environment is much more damaging in compared to gasoline itself. For the final comparison and trade-off, we think that first thing that comes into play is a no free lunch rule when it comes to conventional fossil fuel. As long as your process involves conventional fossil fuel, you will always have emission out to the system. So the question here isn't about which one is a clean way, but rather which one is a cleaner way to solve the issue. So we think that our project solves two questions at the same time because we are using an existing raw material within Malaysia right now. And thirdly, we believe that we are diversifying the energy sector, creating healthy competition within the energy sector as well. And fourthly, we can always talk about developing green technology, but most of the green technology are not commercially viable yet. So the money profit that we made from this project can then be used to fund the research and development to further on the green movement to move on to a greener state of economy itself. And lastly, we believe that engineering technology in its essence is human error-driven mechanism, in which whenever we have a new project, a new idea, rather than fearing the flaws and certain challenges that we have to face, We would rather want to implement it, and along the way, whenever there's an error, whenever there's a flaw, we wish to fix it along the way so we can experiment and try out this alternative rather than not conducting it just because it's a new idea. Mitigated environmental impact and relatively high monetary investment are the only two cons of this, so we think the project is good to go. These are the keynotes data, and we are very proud to present, and we're open for question and answer. Thank you. First, we would like to open the question for the judges. Thank you. Sorry, can you repeat the question? Thank you for the question coming from the judges. We think that the issue here lies not about the industrial sites waste or factories of waste loop oil, but rather the household waste of loop oil itself, because we believe that in developing countries that has yet to have a proper environmental holistic plan to collect the waste. Of course, industrial sites and factory do have proper disposal plan, but we are talking more of household and personal users. And what we can see is that normally for household users, for machines, car and such, they would dump it directly into the drain water itself, and therefore contaminating the water linkage in the area. So we think that this project, I think it's targeted more to reduce the problem in which that the household will have a proper collect plan and it will be used as an input for this, because we think that the less developed the country, the more household waste of waste oil is being dumped directly into the water itself. We think as
for our process that we propose is the new process technology that we propose is we use a combination of hydroprocessing, food catalytic cracking, and we use food catalytic cracking. It is a new a new modification of the technology that exists, because it is actually a combination of reactor and fractionation. So in this reactor, it occurs the catalytic cracking and fractionation after that simultaneously in this reactor. So we can save actually, in terms of economic, we can save cut costs, and also because we introduced a catalyst regeneration unit, so that's why we can actually regenerate our catalyst zeolite. So we actually, at the same time, we save the environment and cutting costs. That's the new technology.
The sulfur content from waste loop oil come from because it's a waste loop oil of various process and machineries to reduce the friction. So when we conducted this study for our subject, when we did the literature review, we found evidence that there are possible amount of sulfur content within waste loop oil as a process after using the machine system. So we would wish to remove it because we don't want it to be burned later on as gasoline. It will be very contaminating to the environment itself. Any question from the audience? Yes.
Previously, you presented in 3 cases for the payback financial parts. You are only considering the selling of naphtha and also the diesel for the worst case scenario. And you are saying you do not plan to sell the naphtha and also your diesel for the best case as well as the base case.
Yeah.
Then what you do with naphtha, because naphtha and there are byproduct which is a must to be there. What you will do with this byproduct when you are not selling them?
Yeah. Thank you for the question. Can we still proceed to answer? All right. Thank you. We think that the first reason, I think that economically point of view alone, we think that all of the products, if they can make money, we should sell it. But we think that because the theme of this year is to save the environment, food, energy, and water, so the first thing is the market demand for diesel and naphtha isn't that high in the first place. Secondly, we believe that diesel and naphtha is widely known to be much more pollutive in comparing. So if our goal of this project was to save the environment, then if you sell a much more pollutive one, then it will be very counterintuitive. So for the storage, we wish to store them or properly dispose them and not being used because the conversion rate for gasoline is quite high. So the byproduct of naphtha and diesel come back can be stored, or at least we wish to not sell it. In only the worst case scenario, only when we need to keep the plant from operating from an economic standpoint of view, then we have to do whatever option that we have right now in our hand, which is to sell the byproduct itself. Because we also think that this project also covers the food and water itself, because we believe that our food and water come from water sources, the fish and the birds who eats onto it. So the lube oil waste will really contaminate the water. So this project can make money, create gasoline for energy, and by virtue also save the ecosystem. So that it's a no-brainer to pick that we should go for this. I think as a Vietnamese studying in Malaysia, I just wish to make sure that the ikan tulis in nasi lemak don't have whistle point inside it. It's from a fun point of view. Yeah. Thank you.